All right, good morning. How's everybody doing today? Good, good. Awesome. All right, so I would like to talk about the new ODP and then go back and review yesterday's ODP and use that as a discussion about more debugging ideas and techniques for debugging and different ways to drill down into what a program is doing. And we'll spend the bulk of the time talking about that, and then we'll go back and we'll talk more about the dialog command. So any questions up front? All right. So let's look at ODPs. All right. So ODP 415, which is open right now. This is a different kind of string processing assignment. So in our two previous assignments, we were taking an input string and modifying it and creating a new output string from it. This assignment is different. We're taking an input string, and what we're doing is we're analyzing it. And in particular, we're analyzing it as if it was an arithmetic expression we were trying to evaluate. So your function is called calc. It takes a string and it returns an int. And the int is meaningful in this case. It's the integer that represents the result of the given calculation. And it's a very simplified type of expression that we can evaluate. It's basically an integer, an operator, and an integer. So your program should expect a string that looks like this: number, operator, number, no spaces anywhere in the string. Okay? And the operator is either add, subtract, multiply, or divide, plus, minus, star, slash. And your function should parse the string, perform the calculation, and then return the result. Okay, parsing the string. Here's the way you want to parse it. Use scanf, look for %d, %c, %d. If it parses with that, it's a good string. Don't get any fancier than that. Don't deliberately go through and try to remove spaces. Don't go through and look for extra stuff. Don't mess around with A to I or looking at ASCII codes or anything. Just run it through scanf and see if it matches a %d, %c, %d. If that does, it will return the number 3 because we're asking it to parse 3 things: an integer, a character, and an integer. All right. So run the input argument, which, you call it whatever you want. Run that through scanf using the string. See if scanf returns 3. Okay. If you cannot parse it as an integer, character, integer, return -1. That's the function value. If scanf does return a 3, though, meaning that this is an integer, character, integer, then you want to go ahead and evaluate that expression. Well, to do that, this character, the thing that matched the middle symbol here, has to be either plus, minus, star, or slash. If it's not one of those 4 characters, return a -2. Okay, that means unknown operator. Otherwise, take those 2 characters, and if the middle operator was a plus, return their sum. If it was a minus, return the first minus the second, and so on and so forth. Okay, that's all you need for 10 out of 10 on every test. So some examples down here. If your string is this stuff inside the angle brackets, if your string is 9 plus 9, your function should return 18. If your string is 9 equals is not a recognized operator, return -2. If your string is 2.3, point is not a recognized operator, return -2. If your string is this is a test that does not parse as an integer operator integer, return -1. Ha plus ho does not parse as an integer character integer, return -1. Alright, if you can parse this as an integer character integer and your character is one of these operations, go ahead and do that operation. Just stick with integers. Don't mess around with floating point. This is an integer calculator. So if you do 9 divided by 8, that should return 1. Don't convert to a double and float and round and add 0.5 and truncate or anything like that. Just take everything as integers. Right? They're coming in from the parse as integers, so if this is number 1 and this is number 2 and your character is slash, just return num1 divided by num2. Alright, so you don't need to get any fancier than what's described in here. Alright, an empty string does not parse as a %d, %c, %d, return -1. Now if I do, 9 plus 9, ha ha ha, that will parse as a %d, %c, %d. Go ahead and process it. Don't worry about the extra stuff on the end. If there's spaces in the beginning that will match this parse, go ahead and parse it and process it. Okay? So the acid test for is this something that you should process or not, run it through scanf with this pattern. If it returns 3, then it's a good parse. And then you just have to make sure that the middle operator was one of these 4 characters. Alright, questions on that? Okay, I want to make a disclaimer here on implementation details. So a lot of times, especially with ODPs, but also with the longer programming assignments, I'm doing things like giving you algorithms, okay, or giving you a particular way to parse your input to see if it's valid or not, or I'll sketch out pseudocode and say, if you do this, this should work. I never want you to think that I'm telling you turn off your brain and just do it this way. Okay, that's absolutely not what I'm saying. But if you're not sure, how your program should respond to a particular type of input, right? In this case, I'm saying take a look at scanf, parse your input with this. If it returns a 3, that is valid input. If you want to parse your input using your own approach instead of using scanf or instead of using this, if you feel like you want to use a %s in here or something else, right, you're absolutely encouraged to do that, right? You've got to explore this stuff. There's no way that you can excel in programming by just doing what you're given, okay? If it was that easy, right, you could make a YouTube video and turn the whole world into programmers. The only way to get better at this stuff is by playing with it. You got to get in there, you got to get your hands dirty, you got to try things, you've got to break things, you've got to fail. You've got to say, I know how to do this, and code it up and run it, and it doesn't work. If that never happens, you're not going to learn. So the bugs, the setbacks, the things that don't work, the things that blow up dramatically and segfault or crash your machine, right? Those are the learning experiences. Those are the nuggets of gold. So I always want you to feel encouraged to try to find your own way to do things. And if I sketch out pseudocode, for moving all your characters in a string down one spot to the left, right? You don't have to do it that way. That's an example. But I absolutely want you to do it the way that makes sense to you. Okay? But if you're, pinched in the 11th hour, or you're not sure what this should do or something like that, you can go back to the stuff I've given you, right, and implement that or work with that and see a solution, right? But I always want you to feel welcomed and encouraged to, you know, if you think you should be able to do it this other way, do it that other way, right? Make it work. And if you think that this should work and it's not working, that is valuable, okay? That's gold. If you think that something should be doing one thing and it's doing something different, that is a huge learning moment for you, right? And I don't know what those learning moments are going to be. If I did, I'd give you a bunch of homework exercises to expose those. But they're different for each person. But when you find one of those, that's a huge learning opportunity waiting to be discovered. And you got to take that case and you got to dig down into it. And you got to say, I was sure this would work, but it did this other thing instead. Drill down into that, figure out what exactly happened. Right? The worst thing you could do at that point is throw away that code and start from the beginning. Because, you just lost a really valuable piece of information. All right. So let's talk about yesterday's ODP. So yesterday we were moving strings down one spot, and the basic idea was, here's our original string. Let's just copy these down one position and copy this first character into the last position, and that should, give us our shifted string. So I sent around some notes in an announcement. And this was basically about debugging, right? So you come up with an algorithm, that's the first step. You implement the algorithm, that's the second step. You get your compilers out of the way and so on. And then you start testing. Okay, so the first piece of my announcement was about testing your code. Running a test case is good, right? And if it blows up, then you know something's wrong. But running one or two test cases and having this thing work correctly, that doesn't tell you that your code is correct. Okay. The assessments that I've written for these ODPs do 5, 10, 20, sometimes 30 different tests on your function or your program to try to explore all the edges. So it's not just the particular test cases that you try, it's also the way in which you try them. So you might be able to call a function and it works perfectly, and you shut down your machine and you boot it up tomorrow and you call your function with a different test and it works perfectly. But if you call that function multiple times in a row with different arguments that can interact with one another, you may find problems. Right? So that's always a good thing to use to exercise your code. Call your function from your main program multiple times in a row with different values. If you're producing an output string, maybe set up that output string to be different things before you make a call. You're trying to eliminate the possibility that you're just getting lucky, that your code is buggy, but it happens to work anyway in the test case that you made. Right? But you want to exercise this thing as thoroughly as you can imagine, and try to expose any possible issues. So let's play around with some code. So here's some sample move code that I cobbled together. And remember, our goal is to take our input string and shift it down one spot, save that in the output. So here's some test code I might have, which says first let's save the first character of our input string. So we'll save that in a character called save. We'll copy the input to the output. We'll go through our loop. And for each character in the input, we will copy, for each character in the output, we'll copy the character after it from the input. So output 0 will be character 1, output 1 will be character 2, and so on. We'll exit this loop when I is equal to the place past the last character, and we'll set the output at that point equal to the input character. Right? So this may look good, and it may actually work well when you run tests. So here's something else you can do, and this is more powerful than GDB in a lot of cases. So this is what I call playing computer, pretending that you're a computer and you're executing code. Okay, this is hands down the thing that I use when I'm writing code, when I'm looking at code, when I'm debugging code. Okay, this is what I use when somebody shows me their code and they're not sure if it's right, or they're not sure why it's doing something wrong. This is what I'm doing in my head or on paper when I look at code. This is my #1 debugging technique. GDB is a good go-to when you have something very large, when you don't know where the problem is, things like that. But if you want to look at a section of code like this function and get a good idea if it's doing the right thing or not, right? Play computer. Okay, so how do we play the role of a computer? You have to turn off your intellect. Okay, and this is challenging, particularly with code that you've written, because you know what this code is supposed to do. And if you're trying to double check this algorithm and you get down here, what does this do? Okay, it takes the saved character, it puts it at the end of the string, right? I've even got a comment I put in here that says that. And when I get to this and I say out bracket I equals save, what am I going to do? I'm going to take that saved character, I'm going to plunk it on the end of the string and say, yeah, the program's perfect. Look at that output string. It's beautiful. Okay? You've got to turn all of that off. You've got to forget everything that you know about your algorithm, about you know, how to manipulate strings. You've got to put all that out of your head. And you are just a computer. Okay? And the only thing you know is the value of your memory and what this instruction says to do, and what this instruction says to do, and what this instruction says to do. And you got to put everything else aside. And it's a hard thing to do. And if it's not working, then you can go into GDB and you can use that to keep yourself honest. So let's play computer here. Okay? And I'm going to try to move the string ABC. So I'm going to do move ABC into some output string. Okay, so we want to write down the contents of memory as we go through this program. So when we call this program, we have two variables already. We have an input variable and an output variable. And the input variable is the value of this first argument. So I'm going to write down in equals, and it's an A, followed by a B, followed by a C, followed by a null terminator, because when you put something in double quotes, there's a null terminator, followed by who knows what, whatever happens to be in memory. And I'm going to put indices up here, just so I don't have to count too much. Alright, and we have a second variable. We have an output variable, which is a char star. And what are the characters in that string? I have absolutely no idea. They're question marks. They could be nulls, they could be the secret recipe for Nestle Toll House cookies, they could be who knows, okay? I'm going to write them down as question marks to say, I don't know what that is. Alright, let's go into our function, integer I. So we're declaring an integer named I, so we have to write down I. What is its value? I have no idea. Okay, now right here, if I started to use I without giving it a value, I would find my problem. Because if I said, you know, save equals I plus 1, I'd say, well, I'm adding 1 to an unknown value. You just found your bug. Okay, so be really careful about each thing that you do while you're playing computer is no more and no less than what the program actually says to do. This says I'm declaring I to be a variable of type integer, and that's all it says. So I'm writing down an I, right? and I don't know what its value is. Okay, save equals in bracket 0. So save equals, well, here's what our in variable looks like. In bracket 0 is the letter A. So save is equal to the letter A. Okay, now we call string copy, which says copy from the input array to the output array. So let me go ahead and let me just rewrite my output array down here. And it's going to be a copy of my input array. So it's going to be an A, a B, a C. String copy will also copy the null terminator. It stops copying after the null. So these are unknown, and not necessarily the same as those. They're just unknown values. Okay, let's go through our for loop. We're going to start off, it says for I equals 0. So now I has a value. It's equal to 0. And we're going to compare it to the string length of in, so let's make a note of that. String length of in is equal to 1, 2, 3, because string length doesn't count the null terminator. So that's a 3. Alright, so is 0 less than 3? Yes, it is. So let's go ahead and do the body of the for loop, which says out 0 equals in 0 plus 1. So out 0 equals in 1. Okay, in 1 is a B, that gets saved in out 0. Let me add indices up here also. Alright, so we've done our first iteration of the for loop. We get to the end of the for loop that says set I equal to I plus 1. So I becomes a 1, we go back up to the top, and it says do this while I is less than string length in. 1 is less than 3, we're going to go into the for loop again. This says out I equals in I plus 1, while I is 1. So out 1 equals in 2. So in 2 is a C, so this is going to become a C. And then end of the for loop, I equals I plus 1. I changes to a 2, go back to the top of the for loop. And it says, is I less than string length of in? Well, 2 is still less than 3, so we're going to do the body of the for loop again. I is equal to 2, so this says out 2 equals in 3. Alright, in 3 is the null terminator. Out 2 changes into the null terminator. Bottom of the for loop, increment I. I becomes a 3. Go up to the top of the for loop. Is 3 less than string length of in? Is 3 less than 3? No, it's not. So we exit the for loop. And now we go on to this last statement, which says out bracket I equals save. Okay, what's I? It's equal to 3. What is save? Save is equal to A, so out bracket 3 is set equal to A. And then we hit the end of the function. Okay, now you step back and you look at what you've got. We're trying to move A, B, C into an output string. What is our output string? B, C, null terminator A, and then a bunch of unknown things. Our function did not work. It changed ABC into BC with a null terminator and with an A, but the A is not part of the string. Okay, right there you've got your evidence that there's something wrong with your function. Okay, so you blink and you scratch your head and you walk around the room a few times and you come back and you say, what happened here? Okay, now don't start trying to fix this. Don't say, oh, okay, so I'll swap the last 2 characters and that'll fix it, right? If you've got buggy code and you add more code to try to change the results to be what you want, you're probably writing bugs on top of bugs, okay? What you want to do is you want to go through your algorithm, and hopefully you've got, something like pseudocode written out. Go through your algorithm and see where in that algorithm you made a mistaken assumption that led to this instead of BCA null terminator. And then go back and rewrite that piece of the code to avoid this bug. Okay, but really important, don't just try to fix up this particular case and say, oh, I'll subtract 1 from this and add 1 to that, right? Make sure you understand why what you wrote is doing this, and then compare that to what you thought you were writing, and then write something different. All right, let's do another example. All right, so here we've got input string. We'll save its length. We'll set an output pointer, and we'll go through all the characters of our string, and we'll set the output character to the following input character, and then at the end we'll save that last character. We'll set that last character equal to the first character from the input, right? And I'll write a test case here where I move A, B, C, and I'm going to print a message which says after moving A, B, C, my output's equal to, and I'll put it inside angle brackets to catch white space. And yeah, A, B, C moves to B, C, A. So I assess this and I get 0 out of 10, and you know, what's wrong? My code's perfect. So let's play computer. Okay, let's go through this move function and see exactly what it does. So again, we're going to move A, B, C and put that into an output. All right, so first thing we do is we have an input variable. So it's an A, B, C, a null terminator, and then who knows. We have an output string, and we have no idea what's in that output string. Right, until you copy something into there, those things are effectively question marks. They're unknown. We have an integer called inlen, and we set that equal to the length of input. Well, what's our input string? A, B, C, null terminator, 1, 2, 3 characters, inlen equals 3. Right? And when I execute this statement, I'm not looking up here. I'm not looking up here, I'm looking here. Right? What's the string length of input? Well, let's see what input is. It's A, B, C, that's 3 characters. Okay? This is the memory of your computer. All right. Integer out equals 0, so I have an integer called out, and I'm giving it a value 0 right there in the declaration, so I know that's a 0. Okay, now I'm going to do a while statement. I'm going to say while out is less than inlen. While out is 0, inlen's 3, that is less than 3, so we're going to execute the body of this while loop. First thing we do, output out equals input out plus 1. Out is 0, so output 0 equals input 1. This changes to a B. And then out plus plus, so we change out from a 0 to a 1, and we go back to the top. Is out less than inlen? Yes, so we'll do this assignment again. Output 1 equals input 2, so output 1 is going to be input 2, that's a C. And then we're going to do out plus plus. So now out is a 2. Come back to our while statement. While out is less than inlen, 2 is less than 3, so we're going to execute the body of this loop again. Output out equals input out plus 1. Okay, I'm not following a pattern here, right? It would be really easy to just, you know, copy these down at a diagonal, because that's what's been happening. Don't do that, okay? You are a very uninspired computer. You don't find patterns. You don't anticipate behaviors. You don't implement higher level functions. You do one thing, right? In this case, what do? I take the value of out and I add 1. 2 plus 1 is 3. I take input bracket 3, that's a null terminator. I take the value of out, that's 2. I take output bracket 2, that's this spot. I set it equal to input bracket 3, that's the null terminator. Right? And you gotta go down to that level. and you got to be very kind of zombie-esque about it. So output 2 equals input 3. Input 3 is a null terminator, so this changes to a null terminator. And then we increment out again, so this is 3. Alright, and then we come back up here and it says while out is less than inlen. Well, 3 is not less than 3, so our while loop exits. And now we have one more statement. Output inlen minus 1 equals input 0. Okay, inlen is 3, so this says output 3 minus 1, that's output 2, which is right here. That's going to get changed. And it's going to be set equal to input 0, which is the letter A. And then we return. Alright, so what is the final value of the string out? It's a B followed by a C followed by an A followed by, I have no idea. It's not a null terminated string. So we just found a very subtle but significant problem in this function. Yeah, it's moving these characters down, it's copying that first character in place of the last character, but it's not null terminating. We had a null terminator in there, right? Because we went through to the last character of our output string and we set it equal to the following character in our input string, which was the null terminator. But with the null terminator that we copied was not where it needed to be. It needed to be over here. And even though this function worked for our first test case, right, that worked great. Let's try something else. Let's just move the string A. And when I run that, it's totally obvious that there's a problem here. ABC turned correctly into BCA, but the string A should have just remained the string A, but it changed into ACA. Well, where'd that CA come from? It came from my previous value of out, from that previous call. And that happened because my output string has who knows what in it. Well, it had, whatever it had the previous time that I ran this. Even though it's a local variable, it's sitting in memory on a machine, and that memory got reused the next time I called my move function. And it happened to have the stuff from my previous call sitting inside it. And if I did a bunch of other things in between those two calls, this might not have happened. So there's almost no way that you can come up with enough test cases to prove that your function works. Right? The only way I could prove this with code would be to call move with all possible input strings and make that collection of moves in all possible orders. Right? And that's computationally not possible. So at some point, you have to rely on test cases and say, yeah, I think I've covered all the possibilities, right? But we can never prove it. It's like trying to prove a theorem in mathematics by plugging in numbers. How do we prove the quadratic formula actually works? Well, we could take, several polynomials of degree 2 and plug their coefficients into the formula, take the answers that come out and show that they're roots. But how do we know it works for all possible cases, right? Somewhere you've got to do something different, okay? So that's what this is. This is a way to try to first of all, see exactly what the computer is going to do, and then when you've got something that you can see is not correct, go back and play this in parallel with your thinking about the original algorithm and see where the disconnect is, right? I really thought that this, the last time through, would take care of the null terminator. Well, it kind of did, but it put it in the wrong spot, right? So maybe I should have done a less than or equal to here. Maybe that would have fixed it, right? Or maybe I should have handled the null terminator separately at the end, right? So this is an imprecise science, right? This is part of the art. This is why, you know, a skilled debugger is such a valuable commodity in a tech business, because this is an art form, right? But it's something you get better at, and you get a lot better at it the more sneaky bugs you encounter. So again, you know, the really subtle bugs that you have a hard time figuring out what's going on, those are the ones you want to track down. Those are the ones you definitely want to dig into as far as you can. Alright, so just for completeness, here's the move function that I used for assessment. So, you know, and it looks a lot like the codes that we just looked at that we saw weren't quite right. So I saved the first character in save array. And if my string is empty, this will be a null terminator. So this is safe, because an empty string always has one element in the array, which is the null terminator. And then I go through all the characters up to but not including the null terminator, and I shift these things down one. And I put a note in here, we've copied the null terminator into the last position, which we're going to overwrite with save. So I could have done string length in -1 if I wanted. But I didn't worry about the fact that I wrote a null, you know, which was this character right here. And then go ahead and set that last position in my output string to the null terminator. Right? So when I get through this, I will be equal to string length. And so in that case, it's going to write the null terminator right here in position 3. And now this position 2 is still a question mark, right? And so I go ahead and I copy that, provided that there is at least one character in my string. So if I is bigger than 0, set output I-1 equal to save. So that copies the first character to the last actual character position before that null terminator. Now if I don't have this in here, if at the end of my loop I just say out bracket I-1 equals save, what's going to happen with an empty string? I have an empty string, string length is 0, my loop never executes, and I has never been given a value, right? I declared I will be equal to 0. I declared I to be an integer up here. I set save to the first character in my input, that's going to be a null terminator. I'm going to set I equal to 0. I'm going to say, is that less than the string length? It's not, so I'll exit my loop. And since I is 0, this is going to say out bracket -1 equals a null terminator. Well, that's not something you want to do. Right? Unless you're trying to hack something, you usually don't want a negative index on an array. Now if we're lucky, that will go ahead and throw a seg fault. If we're unlucky, it will change something somewhere else in the memory of the computer. And that can set up, you know, a change in some variable that somewhere totally unrelated to this in our program is going to cause a problem. And we're going to start debugging this other function that's misbehaving, and the whole problem actually came not from that other function, but from the fact that right here we tried to index an array with a negative index, and that changed the value of some other variable. Right? So even if I plug this in and it works, in my head I'm going to run through this, I'm going to play computer, I'm going to make sure this works for a reasonable string, I'm also going to try it on an empty string. And on the empty string, I'm going to see if I don't do this check first, this is going to be a problem. And after enough times doing this, I'm going to develop an instinct. and say, you know, any time that I do this and I don't know absolutely for sure what the meaning of I minus 1 is, I'm going to go back and see if there's a possibility that it could be 0. And if it is, I'm going to throw in an extra check. And I'm going to make sure that this is not just dealing with a problem. If there wasn't, I want to make sure there wasn't some glitch in my algorithm that allowed I to become 0. I want to make sure that doing this would be reasonable, and all I'm doing is picking up an edge case here. Right? These are the things that you're never going to get by reading, by listening to me talk, by watching videos. These are the things that you get through experience. And this is why I keep saying, right, number one thing you want to be doing to get better at programming is programming. Write code, play with code, break code, fix code. It's that kind of process that's going to make the difference. All right, questions about any of that? All right, so let's play around a little more with dialogues. So we started looking at dialogues yesterday and different ways that we can create GUIs that we can use for homework 7. So I want to just dig a little further into some of the options that are available with this dialog command. So so I think we looked at text boxes. So I can say text box, and I can put in the name of a file, and then put in a height and a width. And it basically pops up a window that I can use. I can move around in here, and I can look at the contents of my file. And it's a read-only view. I can't type in here. All right. In fact, as soon as I type anything, it exits me out because I hit an E. But you know, if I'm in here, I can't move around. So you can also make an edit box. And an edit box was like a text box, but it lets you type inside. So now I've got a window that I can move around in. And I can type into. And so on and so forth. And it's a little rudimentary. But you know, you can move around, you can page down, you can page up, and so on and so forth. When you exit from this dialog, the file is not changed. Okay, the file is unchanged, but the dialog command will output the contents of my updated file to standard out. And we can capture that and we can do stuff with it. So in this case, we didn't capture standard out, so it just sent all of this to my display, but this is, you know, the contents of my file. Alright, so that's an edit box. We can create checklists. So I can say dialog checklist, I can put a title in, height and width, and then how many rows I want in my checklist. And I list triples for each line, so I can have something that I want to have appear on the first line, a tag or something, and something to be displayed next to it. And then a keyword, which is either off or on, which says should that box be checked by default. So let's make all of these off. Right. So I get a dialog box like this. It's titled haha. And there's, you know, my first item with an A, default B, last with C. And I can go through here and I can select these. I can click on them or I can hit a space bar and they toggle and so on. So I can select the first and the last. And then if I say, you know, OK, the dialog command will output these tags for all the items that I selected, in this case, first and last. So if I want to do this in a bash script, right, typically what we want to do is we want to capture this information. So choices equals back quote, and let's run all of this stuff inside back quotes, which will say capture the standard out from this. And let's add this switch that we saw yesterday to say send the output to standard out. So we'll say dash dash output file descriptor 1. And now when we run this, it looks exactly like it did before, but I'll select default and last. And now if I look at that variable, it's got the two options that I selected, default and last. If I do this and I select all three, it's got all three. If I do this and I don't select any, then my choices variable is empty. All right, and this is totally typical of how we're going to do pretty much everything with dialog. Right, you're going to construct a dialog widget, tell it what type you want, things like a title, height and width. Some of these have optional parameters and so on. And then at the end do dash dash output dash fd1, which says send the output of this to standard out. Copy all of this inside double quotes so that it executes it and then replaces this with what was sent to standard out, and then assign that to a variable. Right, so I can change the labels, and so whatever you want to do. So so take a look at the manual pages for dialog. These are the types of dialogues you can construct, and there's options that work for most of these. So options like changing the label on the cancel button, adding an extra title in the back of the main window, setting the aspect ratio of the window itself. You can play around with the colors. You can change the column separator so that when you get the result of a checkbox, instead of being separated by spaces, they could be separated by commas or something else. And you don't need to memorize all of these. You don't need to know all of these, but take a look through and see the kinds of things that you can do. Right? Now, most things in Unix, there's so many ways to do what you might want. So, for example, the calendar dialog lets you specify the order in which the month, day, and year appear. We can change that around. We could also take the order that comes out by default, and we can manipulate that outside of dialog using other Unix commands, things like awk. So you don't, almost never do you need to know, all of the options available for a Unix command. Usually you need to know a small handful of them, and you need to be good at putting commands together to do things. So for example, if I want to list my files in my directory, they come out in alphabetical order. If I want to list them in reverse alphabetical order, I can put them into TAC, which is cat spelled backwards, and TAC takes an input stream and prints it out in reverse order. Right? Now there's also a switch I can put on ls. I can say ls-r, and that will show my files in reverse order also. But if you know how to reverse an input stream using TAC, just take your stream and run it through TAC. So you don't have to learn all of these things. But like I say, it's worth taking a look through here and just kind of seeing the things that are available. Right? Knowing that you can change the colors, for example, is useful if you want to customize your output. Knowing that you can add a drop shadow or remove a drop shadow from the box itself can change the way it looks. And so on and so forth. You can change the time format, the date format, and so on. So take a look at that. All right, and we are out of time. We can also do menus. We can talk about this tomorrow. Let me just show you really quickly a menu item. Or maybe not. So I can say menu, tell it how many menu items I want, and then I can list each of my menu items, and I'm just listing them next to a number, and I can, you know, go through and choose one of these, and, you know, I can just hit the number 1 to select item 1, or number 3 to select item 3, and so on. And once you make a selection, the number, right, whatever I put in the first column, that's the output of the command. And so I could capture that in back quotes with output FD equals 1, and so on and so forth. Right. So think about these pieces, how you can put them together to do homework 7, and we'll play around with that more tomorrow. All right. So we'll talk about more Unix commands tomorrow. I want to dig into awk and start talking a little bit about regular expressions tomorrow. All right. I'll see you next time. Thanks.